Physical Science 20, reaction and the mole, and we're going to look at balancing reactions today. That's the RM1 assignment. A chemical reaction is a formation of bonds, breaking of bonds, or a combination of both. New elements are not made in a chemical reaction. In fact, the mass of the products will equal the mass of what were the reactants. In chemical reactions, atoms that compose the reactants are simply rearranged to make the products. The fact that elements do not change in a chemical reaction is expressed in the statement, matter cannot be created or destroyed. This is true in the case of chemical reactions where the number of each element on the reactant side must correspond to an equal number of that element on the product side. In a chemical equation, reactants are written on the left. This is what we are starting with, and products are written on the right. This is what is made in the reaction. The reactants and products are separated by an arrow. Occasionally, this may be written with an arrow going both directions, a case called equilibrium that you will become more acquainted with next year in Chemistry 30. Atoms are too small for us to see them separate and recombine, but that doesn't mean we can't tell when a chemical reaction has taken place. There are several visual changes that may result from a chemical reaction. These may include the production of a gas, liquid, or formation of a solid without cooling or heating, an unexpected change in color or acidity, the production of light, or the production or consumption of heat. It is important to note that all reactions give off or absorb heat. Heat is a form of energy, and energy is measured in joules. A joule is a rather small unit, so we often express the energy lost or gained in a chemical reaction in units of kilojoules. A reaction that gives off heat is called exothermic. Exo, heat is exiting. So if heat is leaving, we call it exothermic. In the exothermic reaction, heat is exiting. This is the reaction for hydrogen peroxide when it decomposes. The heat term is not usually written in the chemical equation, but rather accompanies the reaction as a delta H term. Since the heat is exiting, the delta H term is negative. Delta means change. The triangle means change. H is enthalpy. That's the nerd way of saying heat. So change in enthalpy, the change in heat. A reaction that absorbs heat is called endothermic. Since these reactions absorb heat, the reaction vessel typically begins to feel colder as the reaction progresses. That's endothermic. Heat is entering the reaction from the environment. In the endothermic reaction, heat is entering the system. An endothermic reaction is produced when ammonium nitrate is mixed with barium chloride octahydrate. Again, the heat term is not usually written in the chemical equation, and since heat is entering the system, the delta H term is positive. Chemical reactions happen all around us every day. Some common everyday reactions include the tarnishing of silver, the rusting of iron, the burning of natural gas, the neutralization of stomach acid, the fermentation of glucose, and the making of ethanol. And then the ethanol turns into vinegar when it combines with oxygen. A chemical reaction will often have letters following the chemical formula. These letters reveal the state of each species involved in the chemical equation. Those states are S for solid, G for gas, L for liquid, and AQ for aqueous. And aqueous means the species is dissolved in water. In the assignment, on occasion, you will see these letters behind the formulas. When we are balancing equations, they will be ignored. This is extra information that has been given to you, but it's not necessary for balancing the equation. So a quick refresher from grade 9. Remember that If we have more than one element in the formula, the chemist often puts a number behind the element to signify how many of that element are present. So if we have a formula like CH4, we've been given one C, and H's, there's 4 of them. If it's H2O, H's, there's 2 of them. Oxygen, there's 1 of them. Also in grade 9, we said when there is a bracket, it is always followed by a number, and that number has to be multiplied by everything that's inside that bracket. So if I'm given calcium nitrate, I have 1 calcium, I have 1 nitrogen inside the brackets, but it has to be multiplied by 2. So that gives me 2 nitrogens. I have 3 O's inside the brackets. That has to be multiplied by the 2. So 3 multiplied by 2 is 6 oxygen. And the last thing you have to remember from grade 9, when we have a number in front of a formula, the number of elements gets multiplied by that number. So we're going to take the same example as last time, but we're going to put a 2 in front of it. So just like before, I only have 1 calcium in my formula. I'm going to have to multiply that by 2, so I have a total of 2 calciums. The nitrogen, we have 1 inside the brackets, the 2 distributed in, so I have 2 in my formula. I have to multiply that by 2, so I have a total of 4 nitrogens. And also, I had 3 oxygens, the 2 distributed inside, giving me 6 O's. I have to multiply that by 2, so I have a total of 12 oxygen. Balancing chemical reactions. As earlier stated, the number of each element on the product side of the reaction must equal the number of elements on the reactant side. The way to easily accomplish this is by, these are the 4 steps that you will follow. First, start with the most complex product or reactant and place a 1 in front of it. Typically, not always, but typically, the formulas that contain the most elements will have the smallest number when balancing. Second, balance the elements so that there's an equal number of each element on both sides of the equation. Save elements that appear in several different formulas to balance at the end. Third, if the equation will not balance, you have to attempt it again, starting with a 2 in front of what you had determined to be the most complex product or reactant. And in the end, you rewrite the balanced equation without using the number 1 in the balancing. Without a number, it is assumed to be a 1. Including it in the formula would be considered redundant. In RM1, you've been given a number of blanks to fill in. It is okay to leave 1s in front of those formulas. But if you were to rewrite that formula again on a separate piece of paper, you would not include the 1s when they were balanced. Example number 1. I want to balance out barium reacting with water to make barium hydroxide and hydrogen. So I'm going to write reactants and products and draw a dashed line down the middle. And I know that the number of elements on the left-hand side, which are the reactants, are going to have to equal the number of elements that are on the right-hand side, which are our products. Now, step 1 says we put a 1 by the largest formula, because typically the largest formula will have the smallest number. That's not always the case, but most often that will be the case. So I think barium hydroxide, Ba bracket, OH bracket 2 is the largest formula, so I'm going to place a 1 there. And when I do that, that gives me 1 barium, 2 oxygens, and 2 hydrogens. Now I can either balance out barium, oxygen, or hydrogen. If I look at the hydrogens, that would be a bad place to start because hydrogen is located in multiple different spots. If I look at the oxygen, that would be a good place to start because oxygen is only located in barium hydroxide and water, so we know those O's will have to balance out with each other. We could also start with barium because I have barium in only 2 different locations, and since I have 1 barium on the product side, I'm going to need to have only 1 barium on the reactant side. So to get 1 barium, I place a 1 in front of Ba, and that gives me 1 barium. Now let's look at the oxygens, because we said we could balance those as well. I have 2 oxygens on the product side. That means I'm going to need 2 oxygens on the reactant side. And in order to get 2 oxygens, I will have to place a 2 in front of the water. That will give me 2 oxygens and 4 hydrogens. Now, I can balance out those hydrogens. Currently, I have 4 on the reactant side. I have 2 on the product side. So that means I need 2 more on the product side. That will give me 4 H's, that's 4H, on both sides. So to get 2 hydrogens out of a hydrogen molecule, I will have to place a 1 in that blank space. Now my equation is balanced, 1 barium on either side, 2 oxygens on either side, 4 hydrogens on either side. Example 2. Again, I'm going to write reactants and products over top and put a dashed line. I'm going to start with C2H2 because I think that is the largest molecule there. And when I put a 1 there, that gives me 2 C's and 2 H's. Now, which element to balance first? Well, probably not oxygen for 2 reasons. It's in multiple different locations, and we don't have any oxygen to start with. We just have carbon and hydrogen. I could start with hydrogen because it's only located in 2 different spots. One's on the reactant side, one's on the product side. Or I could start with the carbon, and that is what I'm going to do, start with carbon. So I've got 2 C's on the reactant side. I'm going to need then 2 C's on the product side. And to get 2 C's out of CO2, I will need 2 carbon dioxides. That gives me 2 carbons and 4 oxygen. Now I can balance out the hydrogens. Right now I have 2 hydrogens on the reactant side, so I'll need 2 hydrogens on the product side. So if I place 1 in front of water, that gives me 2 hydrogens and 1 oxygen. Now I have to balance out the oxygen. I have 5 oxygen on the product side. That means I'll need 5 oxygen on the reactant side, and that does not work. If I put a 2 in front of O2, that gives me 4 O's. If I put a 3, that gives me 6 O's. I can't get 5, so therefore I'm going to have to start again, and that is why we use pencil. So let's erase it all. I'm going to start again with C2H2, except this time I'm going to try it with a 2. That gives me 4 carbons, 4 hydrogens. I'm going to balance the carbons first again. So if I've got 4 C's on the reactant side, I will need 4 C's on the product side. And I will put then a 4 in front of carbon dioxide, and that gives me 4 C's and 8 O's. Now I'll balance out hydrogen. I've got 4 hydrogen on the reactant side. I will then need 4 hydrogen on the product side. So to get 4 hydrogen, I will need 2 water molecules, and that gives me 4 H's and 2 O's. Now on the product side, now that we're balancing out oxygen, on the product side, I have 10 oxygen in total. So that means I'm going to need 10 oxygen on the reactant side. And to get 10 O's, I will need 5 O2s. And the reaction is now balanced. Example 3. Again, I'm going to write reactants and products, put a dashed line. I'm going to start with magnesium hydroxide because to me that looks like the biggest formula. And when I place a 1 there, that gives me 1 Mg, 2 O's, and 2 H's. So to start balancing, I'm going to start with magnesium. It's located in magnesium hydroxide and MgCl2. It's only found in 2 different spots in this balanced equation. So I know the 1 magnesium on the reactant side is going to have to balance with 1 magnesium on the product side. So to get 1 magnesium on the product side, I'm going to have to put a 1 in front of MgCl2. That gives me 1 Mg and 2 Cl's. Now, and there's more than one way to balance, I'm going to go with the chlorines. I have 2 chlorines on the product side. That means I'm going to need 2 chlorines on the reactant side. So to get 2 chlorines, I'll need 2 hydrochloric acids. That will give me 2 Cl's, and that will give me 2 H's. Now to balance out water, I could use hydrogen. It's located in multiple different spots, but it's okay to use now because we only are looking for the 1 hydrogen on the product side, and the 2 hydrogens on the reactant side have been determined. But I think easier than that would be using oxygen, because oxygen is located in just 1 spot on either side. We know they have to balance out. I've got 2 O's on the reactant side. I'm going to need 2 O's on the product side. To get 2 oxygen, I need a 2 in front of the H2O. That gives me 2 O's and 4 H's. So in total, I have 2 chlorines on either side, I have 2 magnesiums on either side, I have 2 oxygens on either side, and I also have 4 hydrogens on either side. Everything is balanced out. We're good to move on to the next question. And that's the end of the RM1 lesson. You are good to begin the RM1 assignment on balancing chemical equations.